Hi, this is Shiyu Liu. Welcome to our project. In my part of this video, I'm going to demonstrate how I design our Dash website and how the users can use it. Our project is to visualize NBA player performances and simulate virtual matches. This is quite entertaining. If you are an NBA fan, you will find it really interesting in exploring the players' recent performances, comparing two of them, and building a virtual fantasy team you want. So, let's check this out. The app.py file has already been started in the local environment, so we can directly come to this Dash website. Let me first give you guys a brief introduction. For our project, we aim to collect, store, analyze, and visualize NBA player match statistics. To be more flexible and entertaining, we designed our application to provide player capability visualization and player comparisons based on users' queries. In addition, we can let the users build their own teams and simulate the match. Our data is acquired from this website. Basketball Reference. We chose this website because its data is pretty up-to-date and authoritative. Here, we can select a player from the options including all NBA registered players. You can also type the name and the match players will be filtered out. So I type LeBron James here. Now you can see a bar plot showing his match stats ranking for this season. There is also a radar plot. It is more intuitive in visualizing his 5 aspects: offense, defense, control, impact, and scoring. A more powerful player will be having a larger area. If we select another player, like James Harden, we can see the comparisons. Or we change one, like Luka Doncic. We can also see the comparison. Users can play with this if they are interested in exploring the player's performance this season. Our visualization part is always up to date, based on the dynamic data we acquired. Please note, offense and defense. These two values also consider team performance, so they do not completely reflect individuals' performance. Actually, we would recommend looking at the player's impact here. This is better in evaluating its contribution to a team and its threat to the opponent. Such capability values are based on the formulas that have been widely recognized. Please check out my teammate Peter's part in this video for more specific explanations. For the data enhancement part, we designed this fantasy team mode. After viewing the players, the users can build 2 teams by selecting 5 players for each team, constrained by players' positions: center, power forward, small forward, shooting guard, and point guard. This can also be a mini game between two users. Let's try this. Team 1. I'll build a pretty powerful team. I'll select Steve Adams for this position. Power forward. I'll just choose Antetokounmpo. Morris for here. James Harden for shooting guard. And point guard, I will just choose LeBron James. Please note, the radar plot is gradually changing along you selecting the players. Adding a player might increase or decrease the tacit or the scoring value. The radar plot features have increased to 7 because we added testing and shooting. Such two features are more relative to players' cooperation in a team rather than their individual capabilities. For Team 2, I'll just select normal players. Carmelo Anthony for here. Paul George. Shooting guard. What about Danny Green? Westbrook. So we can see the team summary comparisons. We expect this match result be a big win for Team 1. This is because they are dominant in every aspect except the tacit. So, clicking the button, simulate the match. If you click this button, our algorithm will calculate the score based on the 10 inputs above. So, Team 1 wins. This is a big win for Team 1. Let's do this a few times. This part is a little bit slow because it requires too much calculation background. So most of the time, the Team 1 wins. Feel free to play with this part, if this attracts you. The project architecture is here. app.py and getData.py are always running. GetData keeps the data up to date from the website, and app shows this user interface. Based on the queries from the users, the program gets data from database, and after the process part through data.py and another file visualization.py, this web page displays the results, supported by the two files mentioned above. Alright, that's it for the Dash user interface part. If you are interested in exploring how the code works underlying this interface, or how the MongoDB database is constructed for this project, please continue and check out Peter's part in algorithm and formula design, or E's part in data acquiring and database design. Thank you.
So let's talk about data acquisition, EDA process, and database design. Our data is embedded in a HTML website page that gets updated every minute whenever there's an NBA game playing. Here's the website. As you can see, the page has a table here, which is dynamic whenever there's a game. And this table is pretty long. Actually, there are around 460-ish player. Oh, here, 466. It's updated. So in order to retrieve such data, we need to crawl the website by using Beautiful Soup package. The Beautiful Soup will give us a plain string formatted HTML whenever we specify tags. Here, we need to get a tbody tag first to find the data table. This is the part. Then we need to find tr, which is the row in the table. So here's a demo for the raw data. I print out the first 10 records. So as you can see, it is pretty messy and contains many tags, and the data we want is hidden in it. Now, we need to do something with the raw data. As I mentioned, we found the tr and tbody. Then within each row, there are many td tags, which is the table column. So by targeting these tags, we'll be able to extract the information in the table. So each player's information is then being converted to a float, int, or even just a plain string, depending on whatever the type is. So overall, the data will then be stored as a list of dictionary containing each player's information. By doing so, we can easily store the data in MongoDB database. So before we move on, I would like to show you the clean data in a data frame here. This is a table which is reconstructed with rows representing players and columns representing players' information. So let's move on. So here's the basic idea of how we store the data. We first create a PyMongo client, and then we generate an NBA database. Within the database, we constructed an NBA collection here. And then we observe the extracted data, which is already a list of dictionary forms, as I mentioned above. So observe will not be time consuming because the dataset is not huge enough. And then we define a function here. It's called 2df. And what it does is that it will retrieve the data in the database as a Panda data frame object. So this object is guaranteed to have the latest version of the data as the source website does. And web crawling and data acquisition process happen every 30 seconds as information may change significantly in the game. So there are 30 columns and roughly 460 records, as I said. Sometimes the table will introduce new records, or even players, as they are just officially enrolled in the games. The data set is not huge, and there will be a 60-second updating in the database, which is not really time consuming, as I mentioned. So here. Thank you.
So after retrieving data from MongoDB, we use the data to measure the player's performance using these statistics. And let's go through them one by one. The offensive rating is the points produced by a player per 100 individual possessions, or points that a player will generate when he tries. The calculation is complicated, which involves the points that a player produced and the number of possessions he played. The defensive rating is the points allowed by a player per 100 possessions that he faced individually. The basis of the calculation is the individual defensive stop, which can be estimated by the number of blocks, steals, and defensive rebounds. The scoring rating is the percentage of time that a player wants to score that he actually scores, which measures the player's ability to score. The calculation involves the number of individual possessions that he played and scored. The control rating is the number of assists for a player compared to the number of turnovers a player has committed, which measures the player's ability to control the ball and make accurate passing. The impact rating is the player's overall contribution in games that he has played in. It estimates how important a player is in the games he played. The calculation accounts for several basic statistics that a player produced in previous games, such as the points he scored, the number of assists, rebounds, field goal made, field goals attempted, etc. It also involves the same statistics that two teams produced in previous games. As we discovered, impact rating is the most important statistic to measure the player's overall ability on the court among these 5 statistics. With the player's statistics, we can calculate their total ratings if we put any of 5 of them in the same team. The first 3 ratings, offensive, defensive, and scoring ratings, are calculated as the weighted sum of the individual ratings, and the weights are based on the time each player played on the court. The control rating is the ratio of the sum of individual assists to the sum of individual turnovers. The impact rating is simply the sum of individual impact ratings. We also developed 2 new statistics for the teams. The first one is the shooting rating. It is the team's shooting percentage that considers 3-point field goals and free throws in addition to 2-point field goals. Generally speaking, it measures the probability of a player in the team making the basket when he shoots the ball. The calculation is based on the points the team scored the number of field goals attempted, and the number of free throws attempted. The tactic rating measures how well the selected players fit in the same team. In other words, is there any chemistry in these players? The calculation mainly considers the players' proportion of points scored in their actual teams. If the sum of the proportions is too high, the tactic will be low. In addition, there are some bonus points if the players are in the same actual team. So after selecting the fantasy teams and looking at their statistics, we can simulate the game. It takes a little while to process. And here you go. The final score is based on the team's ability scores, and we also added some randomness to the scores to simulate the instability of the player's performance on the game day. In the situation of a tie, we also simulate the overtime, and the team with the higher final score wins the game. So here, Team 1 wins the game with a score of 117 to 113. And if we run this simulation again, the final score and result might be different because there are some randomness in the scores. And here you go, the scores are different.